Okay, so I've got my gloves on. We're gonna make pretty simple media today. I kind of like to give you a little idea of all the different kinds of media that there are in the lab. Take a look at these. So all of these bottles that are up here on the shelf, these are different growth media, right? So the ones we're going to make today are these two right here, nutrient agar and nutrient broth. And I'm going to try and zoom in on the nutrient agar a little bit for you, or the nutrient broth, sorry. Let's go to the nutrient agar. All right, so if you go to the nutrient agar, if your vision will allow, you can see that the list of ingredients is pretty simple. We've got beef extract, peptone, and agar. That's it. I'll show you what it looks like in a minute when I take it out, but it's just a powder. If I go to nutrient agar or the broth over here, it looks pretty much the same, except that there's no agar. There's beef extract, there's peptone, but no agar. And so nutrient agar and nutrient broth, they're the same basic ingredients, just they differ with agar. And so this nutrient agar, that's going to make solid media, and the broth, well, that's going to make liquid media. They're both going to start out liquid at first. Well, once we melt the agar, it'll become liquid. And then as it cools and solidifies, it'll become solid. Whereas the broth, when it cools, it stays as broth. All right, so we're going to use some tools in the lab here. We're going to use a scale, looks something like this. We're going to use a hot plate. I'm just hovering my hand over it. I'm not touching it. Just, it's warm. It's hot enough to make the solutions boil. I made a mess, not once, but twice today. I'm hoping in this section I will not make a mess. Let's see how we do. Here's a clean hot plate by comparison. We're going to need two because we're going to make two different ones. We're going to make nutrient agar and we're going to make nutrient broth. And for that, then we'll need both. We'll need some other ingredients too. And so we'll need things like flasks and aluminum foil. We'll need stir bars. We'll need some spatulas. I need to get a couple of weigh boats out. All right. So weigh boats look something like this, nothing fancy to them. We put those on the scale over here. And when we put it on the scale, we always hit tare so that we measure just what we want to measure and we don't measure the weigh boat too. And it should be 0 or really darn close. All right. We have this little contraption around. We have a fancier scale over here. This one's just closer to where I am, where the hot plates are, so I'm using this one. All right, so before we start measuring out good ingredients, I want to have a brief conversation. Let's do the agar first. Okay, so in addition to the ingredients that were listed here, I will put it up there for you to read the directions. I'm going to read it out loud to you because there's quite a bit here. But it's a recipe. You know, that gives you the ingredients, but it also tells you how to make it. So do you know anything else like that? Are you familiar with anything else? Like maybe if you were in your kitchen and anybody made a box recipe? Anybody ever make a box cake? Yeah, it's easy, right? I personally like to make cakes from scratch. And so a cake from scratch has flour, sugar, a little bit of salt, baking powder. Those are the dry ingredients, right? Those are the dry ingredients. And in the box cake that you buy, that's in a little bag, all together, all mixed up, right? This is like a box cake, right? We can go up here and we could probably, yeah, there's, you know, I'll show you. We could go and we could make nutrient agar. There's beef extract, right? There's beef extract. And let's see, where's peptone? It's alphabetical. That's right next to the nutrient auger, of course. There's peptone, right? And I could weigh out the right amounts, and then I auger somewhere around here. And I could make that myself. I could make this just like you would a cake recipe if you wanted to make it from scratch, so to speak, right? But Diffco sells box, so to speak. They sell a container that already has all the ingredients in it, and all you have to do is weigh it out in the right amount and add water. And then heat it up, autoclave it to sterilize it, and you're ready to go. So this is like the box cake of media, all right? So on it, it gives us some instruction. It tells us that we need to suspend 23 grams of powder in 1 liter of purified water, mix thoroughly, heat with frequent agitation, and boil for 1 minute to completely dissolve the powder. That boiling is really going to dissolve the agar and get it in liquid form. And then you autoclave it at 121 degrees Celsius for 15 minutes. Test samples of the finished product for performance using stable, typical control cultures. All right, so at the beginning it says suspend 23 grams of powder in water. All right, so our unconventional use here. This is my whiteboard. All right, we need 23 grams in 1 liter. Can we all see that? Pretty good? All right, 23 grams in 1 liter, but 1 liter is huge. That is a really large volume. And I don't want to make that much. I don't need to make that much to show you guys what's going on. And so I just want to make 100 milliliters. So the question is, how many grams of that nutrient agar powder do I need to put in the flask if I'm only making 100 milliliters? All right, so 23 grams for 1 liter. Well, I think we need to figure out what ratio these are to one another. Like, how much of a liter is 100 milliliters, right? So if we are creative, another way to write 100 milliliters is 0.1 liters, right? You buy that? All right, so this 1/10. So if we multiply 23 grams by 1/10, what do we get? 2.3? Does that make sense? Yeah, so if I'm going to make 100 milliliters of nutrient agar instead of a liter, I need 2.3 grams of nutrient agar powder instead of 23, right? Okay, so 2.3 grams, that's what I need to measure out. All right, so over to my scale I go. So I need a few things to measure. I need a spatula that's clean or has only been used for nutrient agar. No dirty spatulas. And it's still taired, so that's good. And I weigh out, I go in, reach in carefully, and I weigh out 2.3 grams. And I don't weigh out in huge chunks at a time. I go back in as often as I need in order to reach 2.3. Oh, I'm so very close. All right, okay. So done, put the cap back on, put it back up there on the shelf. All right, so how'd I do? Pretty good. So let me tell you, the thousandths, the hundredths, we're just not needing to go that's too picky. 2.3, measuring to the tenths, that will suffice. And so we don't need to be as precise as hundredths or thousandths. It looks something like this, the nutrient agar powder does. You know, cake mix, right? All right, so we need a flask to put our powder in. We also need a stir bar. So stir bars are kind of tiny. You know, this is little, not very big. This stir bar is going to go in there. I lean it to the side and I let it slide in. And then I'm going to take the powder and I'm going to add the powder to the flask. So when I do that, I'm going to cup it. And the goal is to get as much in there as possible. I'm going to give it a good shake. Tap it as much as possible. And it comes out pretty clean. There might be residual on there. If you're really dying to get that out, you can rinse. You can take the flask like this and rinse it in pretty carefully. I'm not going to bother with that, but you could if you wanted. All right, so I've got 100 mils of water already pre-measured. This is, there we go. This is distilled water. This is not tap water. The only thing that's in there is H2O. All right, nothing else to interfere with the growth media. So I add that, I wash the powder that was left on the side down into it. And so now I have a flask look something like this, a little cloudy. Can't see through it at all. That's because the agar makes it that way. I have 2 pieces of foil. I'm going to overlap them in a way such that they're at angles to one another. And then I'm going to cover the top of my flask. There we go, like that. So we need to melt the agar. So I'm going to put it on the stir bar over here, or in the stir. All right, and this has got a heater, and it's pretty warm. I might turn it up a tad bit. A little warm, but it's also stirring. So this is the stirrer. That little stir bar that I put in is magnetic. There's a magnet that's also in the stir, and it creates this nice little vortex. Let's see if you can see that there. Might be able to see it going. So we're going to let that do its thing and warm up and dissolve the agar. While that's happening, we need to do a couple other things, though. We need to label that flask, and to do so, we need to get a piece of tape and a marker. Now, when you're labeling, I got a very, very tiny piece of tape. I don't know what I was thinking. Normally, you should write out the full name of the growth medium. I'm not going to have room for that, so I'm just going to write NA, nutrient agar. Normally, you should write nutrient agar all the way out. And it looks like I might have more space, but I also need to write the date. And I need to write my initials. And so you can see that this big fat Sharpie I've got going here, but that's just not going to happen on that little tiny piece of tape. But that'll work for us. All right, so there's my tape. I also, when I took the tape off, I folded the end back so it would make it easy to pull up and down and put on and off. And I'm going to secure that right there to the flask. It's getting warm, but it's not hot yet. Be careful when you're heating stuff like this, because you know the hot plate is hot, which means the flask is also going to be getting hot. So handle things with care when you know you're heating them, just like you would if you were in your own kitchen, right? So take a look at that, see it's nice and cloudy and opaque, and that's going to change for us. But in the meantime, while that's doing that, we're going to turn our attention to the nutrient broth, right? So the nutrient broth is a little bit different, similar, but different. it's got the exact same main ingredients, the beef extract and the peptone. You know, we all need food to grow, and microbes do too. And so beef extract is just, you know, like, what is that? How do you get beef extract? I don't know, look that up. See what they do to make beef extract. Can't be pretty. No, but beef extract, I mean, it's as the name implies. This is not something very specific. It's just kind of an all-purpose general stuff. And peptone, well, that's just a big old collection of proteins. So it's just a mixture of good things that microbes can use. And so these are pretty, this is a pretty general growth medium. So nutrient agar and nutrient broth, those are all-purpose growth mediums. Let's see, let's pick this one up here. This one's fun. Check out this agar. Look at the ingredient list on that baby. Right? So we've got pancreatic digest of casein. That's a milk protein. We've got peptone, and there are two different kinds of peptone, curiously enough. Dextrose, saccharose, dipotassium phosphate. All right. We have trypan blue and crystal violet. I wonder what color this is when it gets made. I bet it's a blue purple, huh? Yeah, it totally is. So this is Midas salivarius agar powder that's used to make Midas salivarius agar plates, and it is a beautiful blue purple color. So different growth mediums are needed for different organisms, and Streptococcus species are super picky. We refer to them as being fastidious, and we're not cursing at them. We're just, you know, recognizing that they have really specific growth requirements, and so we like to provide that for them if we can. If we want to grow them, we have to provide that for them. And so that's something like this would do that. It would allow us to culture Streptococcus, whereas Streptococcus, it won't grow on this. It's too general of a media, not specific enough. All right, so this is a very complicated media, but we're sticking with the simple just for demonstrations purposes. So nutrient broth, it differs from the nutrient agar in one ingredient. It does not contain agar, which means that it will always be liquid. Obviously, we're going to make it as a liquid, but it will remain liquid long after we're done. So we need to weigh out. Clean weigh boat, new, never been used. Tear the scale again. We need to read the directions, because even though it's the same, so to speak, as in like all the ingredients are the same, DIFCO might package it differently, right? And if we, sure enough, if we look in here, it says suspend 8 grams in 1 liter. Woo, good thing I read that, because if I had done that the same way as I did the nutrient agar, we would be adding way too much, right? So 8 grams in 1 liter, but I'm sure you know by now that I'm not going to make a liter. I'm only going to make 100 mil. And if I'm only going to make 100 mil, how many grams do I need? This says 8 grams in 1 liter. So if I'm only going to make 1/10 of a liter, then I only need 1/10 of 8 grams. So 8/10, right? 8/10. Grab my spatula. Again, you should use a clean spatula or the same as you use for the nutrient broth before. Like this is not the agar one, all right? This is not the agar spatula, new spatula. All right, it's tiered. It says 0. And now I'm going to go to just 0.8. Halfway there. All right, not quite as good as I did last time, but I got it, 0.8. So different media. It's similar, right? Really similar, but different. All right, let's check on our nutrient auger. How's it doing? Oh, starting to clear up a little bit. Looking good. All right. So let's take this now, the nutrient broth powder that we have, and add that. Need another stir bar, clean stir bar. Slide it in. Take our powder. Same, just empty it in best you can. Sometimes it helps to tap on the outside of this. All right, very good. All right, so now we have it in there. All right. Add our water, pre-measured to 100 ml. All right. Anybody ever dissolve like a bouillon cube in water? It smells kind of like that. It smells edible. I would totally drink it if it were sterile. There we go. Cover with aluminum foil again. I'm going to use this hot plate over here because the other one's busy, right? And set it to stir. So this only said to boil for a minute. The idea is to dissolve the powder. You can see it's spinning. You can actually see the stir bar in the middle there. Cruising pretty fast. So we'll let that mix. Usually you don't want to spin it quite so fast. Minimize the amount of broth. We don't really want to, we're not blending it, you know, we're not trying to make a meringue or anything. All right, get it spinning. This is clearing up really nice. You can see it more and more. Turn that up a tad bit. All right, so we're gonna give this a good minute. Hopefully the agar will clear up for us and dissolve. And then the nutrient broth powder will go into solution. In order to put that label on better, we need to label our other flask. We got a little bit longer piece of tape here. Really, I just need a fine tip Sharpie, don't I? There we go. Nutrient broth, date. And I just use my first two initials, or my first and last initials. If you work in a lab with people that, with a lot of people, you may have to use your middle initial just to differentiate yourself among others. There we go. That's looking really nice, don't you think? Nice and clear looking. That's the nutrient broth. This one's getting better. I'm going to give it a little bit longer. You can tell it's not quite dissolved yet. So once these go into solution and they're ready to go into the autoclave, we will make our way across the hall. We made media last class, last section. Their media is in the autoclave right now. And we will take theirs out and use theirs in order to make some plates. I'll show you for some plates. And then we will go downstairs to the lab in order to inoculate some plates. So I had you guys on the schedule, it says to look through experiments or exercises 18, which is the media preparation, and then, which we're doing now, and then the experiment 6, I believe it was, ubiquity of bacteria, right? And that one's all about culturing all sorts of places. If you read through the exercise already, it suggests all sorts of places. the floor, the sink, the door handle, really anywhere you can think of, anywhere you want to know, hey, are microbes there? All right, how's that agar looking? Can you tell it's becoming pretty clear? Yeah, I hope so. Yeah, so I think it looks perfect. A little bit warm, that's good. Not too warm to handle, but still, we're gonna take that flask and the other flask. You should always be super careful when handling things that might be hot. All right, so please don't burn yourself. I'm gonna turn these off because we're done using them. Bring it over here. But you can see the bubbles starting to come off. So it was boiling nicely. This one, I'm gonna turn it off as well. Take it. All right, so we're gonna cruise across the lab. Gloves. And make our way to where the autoclaves are. All right, so this is the media prep facility, the other part. All right, so I'm gonna show you, I'm gonna back this up for a second. I'm gonna show you what an autoclave is. This is a more modern one, if you will. You can see it's got a touchpad right there to work with. I don't like that one, but it's open. You can see that there's a chamber inside. It's nice and cozy. When in use, this door goes up and closes. And so this is the one I actually love to use. This is the manual autoclave. Some bells and whistles you should be familiar with. Up here at the top, this is the pressure gauge. Right now you can see it's at 0. I hope you can see that it's at 0. There's an exhaust valve. This one right now is all the way, or was open a little bit. When it gets to 0, this can be opened all the way. All right, it needs to be for our next purpose. If we go down, we'll see a temperature gauge. And we follow the red gauge. So hopefully that's pretty clear to you guys. If we look at it right now, it's pretty chill. 42 degrees Celsius. When we turn it on, it's going to go up and around past 100 degrees Celsius, past 120 degrees Celsius to 121. And we need it to be at 121 degrees Celsius and 15 pounds per square inch of pressure in order to sterilize the media. So I put in the media from the last class, and it's sterilized and it's cooled down now. So it's ready to come out. So I'm going to show you how to go about that. So this is the handle, and it takes 2 hands to undo it. It is quite strong. I am not weak. So you've got to give it a good tug. When you do, you should step back as you open it because steam will start to rise. Again, this has been, so you may or may not be able to see, but there's steam rising. So it was hot in there, right? And granted, it's only at 42 degrees Celsius right now. It was at one point quite hot. So you should always be careful. So inside, looks something like this. You can hear my voice changing now that I'm halfway in the chamber. No, my head's just sticking in. If it were a really hot autoclave just finished, you would not be able to do that. But you can only open the autoclave door when the pressure is 0 and the temperature has gone under 100 degrees, right? And it's well under 100 degrees Celsius, so we could open it. The reason you have to wait until it's down to pressure of 0 and below 100 degrees Celsius is because you don't want there to be a big pressure change. For one, the door probably won't open if the pressure is higher, but if you were able to open it by some brute force strength that you might, superhuman strength that you might have, if it's above 100 degrees and you open the chamber, the solutions that you have inside will shoot out. All right, they will super boil out, if you will, and you don't want that to happen. And so you should always wait till the pressure goes to 0, the temperature falls below 100 degrees Celsius in order to take them out. Now I've told you that this is at 42 degrees Celsius. And so it's well cool enough. But normally when you take stuff out of an autoclave, you should do so with gloved hands. And so these aren't just any old gloves. These are heat resistant gloves. And so I feel no temperature change at all. No pain at all. Should not. All right. So I took those out and just set them on the cart. I'm going to put the next ones in. And to do that, I'm going to put them back on. I just swapped the trays. All right. And so I have a tray. So there's my nutrient broth in there. So that's the media we just made. Before I close the door, I need to add a piece of tape to each. This tape is called autoclave tape. And right now you can see it's all the same color, right? But after I autoclave, that's going to change. This is the flask that was just autoclaved. You see the tape where my thumb is? It's got stripes on it, right? Black stripes. That lets me know that the autoclave reached its temperature and that that's sterile. So I'm going to close the chamber now. You have to push on it, turn. If this were the automatic one next to me, you would just push the button and the door would close by itself. This, you have to do it by yourself. All right, nice and snug. Going to flip the switch. Ready? Switch. The valve stays open until the pressure goes up, right? Here's the pressure, it's starting to move. And it'll make its way to 15 psi. And then the temperature has also started to move. And as it goes up, the pressure inside changes, it's going up, the temperature's going up, and we leave this exhaust valve open until the temperature reaches 100 degrees Celsius. And at that point, we can close the exhaust valve, and the temperature will keep increasing until 121 degrees Celsius is reached. That usually takes about 5 minutes to happen. And so we are going to go pour some plates while that is reaching 100 degrees Celsius. All right? That way we're not wasting time. We also need to pour these plates before the agar solidifies in the flask, right? So this was nutrient broth that we made last section. And see my label, do you know why that happened? Because I accidentally made a mess. But this is nutrient agar. You can kind of see the remains of Na left there. And I didn't fix the label before I autoclaved it. So this is nutrient agar. If I let this cool here, it'll just be a chunk of agar in the flask. You don't want to do that. That's never good policy. So I'm going to take this and put it on the lab bench. And I'm going to grab a sleeve of plates. All right, who wants to take a guess as to how many plates I'm going to get out of that 100 mils? Let's see. All right, so I'm going to grab a stack. Always better to grab too many. That way, you can always stick back in what you don't use. The plates, when I take them out, grab two over here I didn't use earlier. So here's an agar plate. It's plastic. These are plastic ones. They make glass ones too that you can clean and reuse. Those are more eco-friendly in one way in that you don't throw away plastic, but you have to wash them with soap and water and sterilize them. And so energy-wise, probably a toss-up. All right, so plates are like this. There's a lid and there's a bottom. The lid is bigger than the bottom so that it can sit on top comfortably. All right, lid is up always when you pour the plates because you want to pour the agar into the bottom of the plate, right? So I need to grab one other thing. I need to grab a stir bar. I'm not going to stir anything with this bar. I'm going to use this to hold on to the magnet that's in the flask so that it doesn't come out. You can also use it to get it out and remove it from the flask altogether. I'm just going to leave it on the side. All right, so I have my stack of plates here. I'm going to uncover this foil, just loosen it, and then I'm going to pull it to the side. I'm going to go to the edge, and let's see if I can tilt that even better. All right, you won't see me pour the bottom plate, but as I make my way up, you'll see me pour the other plates. Each time I'm just grabbing the lid of the next one. That's it. Did anybody guess 4? Don't worry if you didn't, that's okay. All right. So there's my stack of plates. You can tell which ones have agar in them and which ones don't, right? So these ones don't. We don't need those anymore. We put those back in the sleeve. So these now are agar plates. Notice that I poured agar in about halfway, right? And it'll take about 5 to 10 minutes, depending on how hot the agar was, for it to solidify. When they do solidify though, you always store plates upside down, even if that means the plates are going to go in the refrigerator to be stored or whether they're going to be used, you always store them upside down. But I can't turn them upside down until they solidify, right? So that takes some time. So we're going to leave them on the bench to do that. Here are the plates from the first section. You can check them out. You can see the difference. Those are still liquid. These are now solid, right? Nothing in those, right? All right, so we can now take these though because they have been solidified and we can turn them upside down. One reason for doing that and storing them upside down is, let me show you that top plate. See how much condensation there is on that top plate? If we leave it right side up like that over time, it will rain down on the agar. So it's always best to store them upside down. Now, not all the plates have that condensation on top. See how nice and clear that is? Only the top plate in a stack like this is going to have that condensation because all the other plates benefit from the warmth of the agar above it. This has cool air above it, and so there's going to be condensation forming on the lid. It's kind of a cool little experiment there in condensation. All right. So, okay. I think we should go back now and make sure that our temperature is, close your eyes if you're going to get dizzy. I'm traveling. All right, there we go. Temperature. All right, can we close the exhaust? Yeah, it's well above 100. It's actually already sterilizing. It's already past 121 degrees Celsius. So we're going to close the exhaust. And now we count 15 minutes. We're not going to stand here for 15 minutes. Don't worry. That would be a horrible use of time. But it's going to autoclave, and I'll take it out later. You've already seen the end part of it. I did want to point out something, though, before we head down to lab to swab places. Nutrient broth, I already told you, once you make it, it stays broth forever, right? Well, this is an agar deep, and the solution of nutrient agar that I made earlier, I put some in a tube and I let it solidify, let it cool down vertically. And so it made a deep. Now nothing on, this is, right? It's not going to move. I'm turning it upside down, right? It's like a plate, but in a glass tube, right? So we will use a deep later in the semester. I'll show you what that's all about. This is a slant. How cool is that? So notice that it looks like somebody carelessly knocked this rack over. They did not. In fact, they took nutrient agar that had been sterilized and they put it in at an angle. And in fact, you can sterilize it at an angle. You don't have to, you can sterilize them upright. And then when you take them out of the autoclave, you lean the racks down. And when they cool, it solidifies into a slant. The cool thing about a slant is that it's got greater surface area than a deep does, right? And so they have different purposes. So we will use slants. I'm going to put that back in just for fun, even though it's already solidified. And this is actually nutrient broth here, so I'm taking it back out. But same idea. So you can make solid media, not only in the plates like we just poured, but you can make slants and you can make deeps as well. You just have to transfer the solution into the tubes before you autoclave them, so that when you take them out of the autoclave, you can either slant the rack or leave it upright to solidify, depending on whether you're making a deep or a slant.